So,
Hey, how are you? Good for you turning the camera on. A little bit late, but that's okay.
Zoom decided to be a dickhead and update at the wrong time.
Yeah, I understand. Okay,
You
what's
actually?
yes? What's the homework?
Yeah, before I get into that, I actually got accepted at Auto U.
That's excellent. Ottawa U's a good school.
Yeah, to be specific, Bachelor of Science in Chemistry.
Good. Yeah, they've got a good program.
Yeah, I'm a chemist.
You must be excited.
Yep.
Yeah. So, just so you know, living away from home is kind of fun too, but it's cheaper to live at home.
Yeah, I plan to live at home still.
You plan to live away from home?
No, live at home.
Yeah. Okay. It's definitely less costly. It's a good.
Mhm.
It's a good plan. But it's also fun to live on your own. Okay, homework. Congratulations, though. That's pretty cool. I'm
Yeah,
excited for you. University's great.
sure it is.
Don't just focus on the courses. Like, get around the campus, get to know things around the campus.
Okay, that's all right. Here, I'll take out my piece of shiitake homework.
Negativity kills.
At least I didn't swear about it though.
Well, you will by the end of the session. You'll swear at least twice.
Really?
Yeah.
Oh, right. Just share my.
Yeah, and I disabled the thing a long time ago.
No, you didn't.
Yeah, yeah, you're able to share. Let's have a look. So these are all like log formulas where you have to solve. Um, Sometimes you're given the time. Well, in this case, you're actually, yeah, you're given the mass on the left side. Let's
Mm.
see if you did, yeah, log both sides. Yeah, that's the rule of logs. That's the only way you can take the t down. Yeah, multiplied by 8 on both sides. Yeah, great.
Yeah, I'm not gonna bother with the rest because I mean with the rest of this section.
Okay, just because you know how to get to it.
Yeah,
Okay, next.
yeah. I already
Yeah, I just
the,
want to see.
the teacher
7.
already did 5A on the board as an example.
Yeah, okay. Can you explain what he did, though? Walk me through it. So you see 49x to the minus 1. What happens right below the 49?
He switched it so that they have the same base. So 7 squared is equal to 49.
Yeah,
So
and what rule can he use to get rid of that squared over the 7?
you can multiply the by x minus 1.
Yeah, it's like a power rule.
And on this side, he represented the square root as a power to the half because it's essentially the same.
Yeah, and then you can combine the exponents to get 7 3/2. Now explain to
Yeah.
me the line just when the sevens disappear. The next line.
All right.
How does he go from that with the sevens to the 2x minus 2 is equal to 3 over 2?
He multiplied
No, no, below that.
here
No,
or
line after
third.
that. How did he get to that fourth line?
He got that fourth line because when they have the same base, they must be equal.
Yeah, the exponents must equal. Yeah, okay.
And then he did plus two, one,
Yeah, and then
you
he
know,
just did algebra.
yeah.
Okay, next. All right, this would be similar. This be similar. Let's see, you used a quarter, which is 1 over 2 squared, which is 2 to the minus 1. And once you got the base the same, you made their exponents the same, then you solve for x. Exactly. Okay, how do you do for c?
We shall see. Pun totally intended.
I wouldn't do that in university. You'll get beat up.
Oh yeah, because no, that wouldn't happen. There's too many witnesses at university.
Well, and if the pun is that bad, though, people might turn away and pretend not to see what's going on. You know, they might say that somebody needs to beat the puns out of that guy.
Okay, no, that's a terrible pun.
No, because there's no pun there. Okay, what can 8 be expressed as?
It can be expressed as an oh, so so
Ah!
what's green, Mr. Clay?
No, you don't want to. Oh, you're just stealing the symbol. Okay. Yeah, but
All
even
right,
the
so
even the radical can be expressed differently.
Yes, it can. Uh-huh.
What's
I
Yeah, I know you know it. What exponent is the same as a square root?
oh, 1/2. Yeah.
Yeah, so you can make it as 8 to the exponent of 1/2. Now, is there a way we can turn, what about a quarter? What are we looking for there?
I guess we need to make that half a base of 8.
No, no. You can't really make it an 8 because you can't square 8 to make 8. You can't square 4 to make 8. You can't square root 8 to make 4. But they do have a number in common.
2?
Yeah. So if you turn that 4 to a 2, you would get 2 squared and then 2 to the negative 1. And if you turn that 8 into 2, you'd get 2 cubed.
Hmm.
So in this case, they want you to figure out how to convert both numbers. Let's see if you can do it.
Um, we'll just go to the next line.
Yeah, you want to keep all your lines. Yeah. Now in this case, you want to put the 8 in a bracket as soon as you convert it.
Oh, yeah, I see.
Because there's two of them. Now, once you have two exponents, you have to make a bracket. Yeah, 2 cubed. Now, 1 over 2 squared has another version.
Meaning what?
Well, what is 1 over 2 squared if you didn't want to leave it in the denominator? How would you get the 2 to the numerator on the left side?
I would multiply it.
Nope. What is 1? See, it's harder to see when it's written like that. What is
Actually,
1
I'll
over...
switch to paint real quick.
Okay. No, just leave that there. Okay. In Paint has a text feature, and you can just
Perfect.
copy text to the text feature. Here, I'll show you. Get to Paint. Just don't do anything. No, don't do anything. Just get to Paint. Now,
Mm,
you see the text, a little A up there?
yes.
Click on it. Make a big square. And now hit Control V. All right, well, not quite. Didn't quite work. So anyway, you don't need to do any of that. We don't need it all. Let me just go back to Paint. Get rid of all that junk. Get rid of it all. Draw me a 1 over 2 that isn't like on the same horizon. Like 1 over, yeah, use the paintbrush. Yeah, 1 over 2.
Actually, wait.
I just want a rough idea. 1 over 2 squared. We would never leave it like this. We always want the 2 in the numerator. How do you get a 2 that has an exponent to the numerator?
Um,
It's okay, so now do equals. Do equals. This is equal to 2, 2 to the power of something. What do you think that power is? No, that's the right side of the equation. We're not working with the right side. The right side's fine. We're trying to just equals to 2. Put a 2 there. All right. Now, there is an exponent I can put over to this 2 that is the same as 1 over 2 squared. What do you think that exponent is? There's an exponent I can... Yeah. Not negative 1, because what's
oh,
the...
wait, I know what it is.
Yeah. Yeah. Those are the same thing. So you always want to do this because you want to work with numerators, not with denominators. You never will solve something in the denominator.
Hmm.
So that means we had to convert the 1 over 2 squared to 2 to the negative 2. So now you can go back to your drawing board. So now we know on the next line, instead of 1 over 2 squared, on the next line, we can write 2 to the power of negative 2 in brackets. Now, there's a rule that we can use for both of these.
Yeah, I can expand these,
Yeah,
essentially.
yeah. So the next line, it becomes what?
I'm working on it.
And that's incorrect, so go back and expand it correctly. So, is that minus 8?
Yeah.
Good. That's correct. You now have the same base. What rule
So
can you?
that means
Yeah,
minus 2x minus 8 must be equal to
3/2.
3 over.
Yeah.
So here, let me do some algebra here. Okay.
Mm-hmm. Now 8/2 is the same as 6. Or 8/1 is the same as 16/2.
8 over 1.
Yeah. See on the right side, you're gonna have to add them somehow.
Wait, now I'm
Yeah, that's okay. Keep doing what you're doing. You're on the right track. Next line. How do I add 8 to 3.5?
here. I'll do it in Paint.
No, you can do it here.
I'd prefer to do it in Paint so I can see.
Time wasting. 3/2 plus 8. But what is that 8 over actually? Yeah, so we want to convert that 1 to a,
2,
which means we have to multiply both top and bottom by,
2,
yeah, so you got 3/2 plus what?
16 over 2.
Yeah, so
So
yeah.
that means 19 over 2,
Yeah, there you go. That's it.
which, no, it can't be simplified. 19 over 2.
No, you don't simplify it. You just leave it as 19/2.
Just perfect.
So minus 2x is equal to 19/2. What's the last thing you do?
Divide everything by
Yeah, and this
minus
is why I
2.
like multiplying by the reciprocal, because it clears up this mess of dividing a fraction by a fraction. But anyway, you could divide both things by 2, -2.
Here, I'll just go on to the next line.
Yeah, this is why I like multiplying by the reciprocal -1/2 instead of dividing by 2. That's okay.
Yeah, and divide by minus 2.
Yeah,
Is it minus 2 or 2?
it's -2. You're right. But you got to divide both sides.
Yeah, I know. I'll figure it out.
Oh, God, what a mess. It's -2. You didn't write it right on the right side. You can't suddenly change the sign.
Actually, wait, I can just multiply by 1/2.
Oh, -1/2. That's correct.
Yeah, so I'll just do.
That's called multiplying by the reciprocal. That's what I said 9 times.
Hmm.
So what is that? That's just x. Is equal to 19/2 multiplied by -1/2.
And so it's this.
Yeah. And just to let you know, when you divide a fraction by a number, the denominator just is a multiplier of that number. So you divided by -2, and then the denominator became 4. Okay, that's good. Now, what number do you think that 1296 and 36 will have in common?
3?
I don't think it's going to be 3, but we can try. You can always square root 1296 and see if it has a square root. It does.
Well, thank you for the spoilers. 36.
Oh, so the base is going to be 36. So you don't have to do anything to the left side.
Nice. Very nice on this one.
Yeah.
Is it weird that I haven't yawned a single time yet?
No, you'll yawn.
Oh
Ooh,
yeah,
that's an extra 0. You forgot the power of x. You forgot the power of x. You don't want to lose easy marks. It's nothing more frustrating than throwing away 25%. Right, so now you can realize that. Now a little bit different this time. We got to get all the x's to the same side.
Let me think about this.
How do you get anything from one side of an equation to the other?
You tell the story.
No, only when the x is all alone can you tell the story. In this case, the x's are on separate sides of the fence. So you got to bring the smaller x to the bigger x. So how do I get rid of a plus x on the right side of an equation?
You minus the x.
On both sides. Yeah. There you go. And what's x minus x?
Diggly squat.
Well, it's 0, right?
Yeah, so nothing.
So now
Diggly
what's
squat.
2x minus x? So x plus 4 is equal to 0.
Oh, then I can say,
I think you swore there.
I said, that's not swear word.
I think you swore.
Whatever floats your boat.
Right. So those cancel, and you're left with what? X is equal to what?
I'm left with -4.
X is equal to minus 4. And you can always go back and verify your answer. How do you go back and verify that you got the right answers in these things?
I substitute -4 in for x
Into the
in each side.
original equation. Yep. Now, the next one's a little tricky. And the secret is you got to get that 2 to the power of 2x plus 2 all alone. How would you do that?
I use a logarithm.
No, how would you get, you want to leave the 2 with the power alone. How would you get rid of plus 7?
Oh, I minus it
Yeah,
on each side.
yeah, that's the first thing you got to do here because 71 has nothing to do with this and the 7 has nothing to do. It'll be clear once you get rid of it.
Yeah, so now my parents are calling me the chemist since I got
Well,
accepted
that's
into.
good.
Yeah,
Right?
yeah,
Yeah,
no,
but
it's
parents
good.
are proud. They always want to do that kind of
Yeah,
silly
I know.
stuff.
I like it.
Yeah, you forgot to subtract 7 from the left side there, chemist. By the way, chemistry balancing is very much like this, and we should cover something balancing a chemistry equation, a trick.
Those are easy,
Okay, never mind.
but show me the trick anyway.
I will. Okay, so what happens? Those sevens they cancel, and what's 71 minus 7?
70. It's 64.
Yeah. So does 64 have a 2 power?
Yes.
What is it?
I'll write it.
Well, I'm not getting any younger.
Don't you just love it when adults say all this stuff? He's like, oh, these dishwashers aren't gonna wash themselves.
Well, that's true.
Yeah, no shit.
Oh, that's at least this. I think we'll count that as the first swear word.
Yeah.
So now that the bases are the same, the rest is easy.
Actually, no, 6.
Yeah, there you go. 2x plus 2 is equal to 6. 2x is equal to 4. X is equal to 2.
How many swear words into the email like Harris? Are we doing the baseball thing? Or
Sorry? Say it again?
no, never mind.
No, I'd never do that. It's so rude.
Fine. Are we doing the baseball strike thingy or something? What?
No. No, you have to, at a certain, now that you're a chemist, you at a certain point you have to have your own standards to live by. No, you're not living by my standards.
Hmm.
Yeah, there you go. Now, what do you think 9 in the next question? What do you think 9, 81,
Oh,
and
they all have 3 in common.
yeah, there you
So
go. You'll better do that then.
I should get them all to be a base of 3.
Yes. Yes, indeedy.
Indeedy.
Yes, indeedy. Yeah.
Do you know what subject I hate?
I don't know.
English class
Why?
because it's annoying. Like, when am I ever going to analyze a novel?
Well, people do all the time. My John, that's a whole field.
Yeah, but we don't. Yeah, but I doubt people write essays about it. So this is 3 hours. 3 to the 4. All right, so this is all equal to 4x plus 1 to the left side. Is that correct?
Hang on. 3 to the 3 to the x, yeah. And
Oh,
then
wait,
3
no,
to
it
the
isn't.
4, and then 3 to the x. Why did you separate? Oh, yeah, I see. You made it 2, and it's 4x plus 2. Yeah, that's right. Now, you got to solve the one in the bracket first.
This is just 3x.
Yeah. Now, what's the rule there? When you have 3 to the base multiplying 3 to the base, what's the rule of their exponents?
You add them.
Yeah.
But you can't add a 4 plus 3x, can you?
Yeah,
So,
you can. Look in the left
so
side. It's got 4x plus 2. So, what does the
oh,
next?
4x plus 3x?
No, no, just do the next line. Just
I
do the
am.
next line.
Mhm. Are you giving me the silent treatment?
No, I'm waiting till you get off your butt and do the.
I did. It's literally the exact same one, so I just did the next
Okay,
line.
so how would you add to 3x plus 4 on the right side?
I would do
How's it
4
added on the
plus
How's it
4.
added on the left side? By the way, it's 4x plus 2. So how would we write 3x plus 4 on the right side?
Oh, 4 plus 3x.
No, yeah, you can do that. So it becomes 3 to the power of 4 plus 3x.
It's freaking awesome.
It is awesome.
All right, let's do this.
What?
Let's do this. Shoot.
Holy cow! I don't know about that.
That's what I said. Shoot. All right, first I'm going to move the 4 to the other side. All right, 4 minus 4. Stiggly squat. And then I'll move 4x. Okay, I made a mistake here.
You did it?
No, I made a mistake.
You made a mistake. What's the mistake here? So you had the exponents 4x plus 2 is equal to 4 plus 3x. You subtract 3x from both sides first.
Ah,
Yeah, it doesn't matter if you subtract, but you want to leave the numbers on one side and the x's on the other. So really your mistake was right away when you subtracted 4. You should have subtracted 3x. So just essentially delete everything. Yeah, so
damn
right
beat.
there, you leave the 4x plus 2 there,
Mhm.
and it's equal to plus 2. Okay, there you go. There you go, it's equal to 4. There, you got it. So the 3x's disappear. Now the 4x minus 3x is just 1x. So that's just 1x. 4
All
apples
right,
minus 3 apples is just 1x. And then you got to get rid of that 2.
I'll do it on the next line
All right.
because I'm just that good. This is equal to jack squat. All right. So for x,
Yeah, this is a tough one, and it's very interesting. So I'm trying to figure out both sides by 5. Yeah, I'm trying to figure out the 4 plus 4 to the power of x plus 4 to the x plus 1, I believe is 5 times 4 to the x. But hang on.
actually, I think I have an idea.
Okay.
They have the same base, so that means x plus 1.
No, you can't do it like that.
Why?
You can't. That's only
They're,
when one base is equal to another base with the
4
same.
and 4 are the same.
Yeah, so what?
Wait a minute.
Can't do that. It's only when you have one base equaling another base on the other side of the equation.
Uh,
Okay, but
that's
here.
a,
Now I'll show you. I'll show you what's going on. Hang on. This is a conceptual one.
what's a conceptual mean?
It means you got to look at real life situations first to understand it. All right. So if I had 4 to the 3, well, let's make it even simpler. If I have 4 to the 1 and I'm adding it to 4 to the 2. 4 to the 1 is 4. 4 to the 2 is 16. And I end up with 20, right?
Hmm.
20 is the same as 5 times 4 to the 1, isn't it?
Yeah.
All right.
Wait, hold on. Why don't
Yeah.
we just say
Yeah, just walk with me before you
4 to
run.
the 3?
You can't. You cannot. Because that's not what's going on. 4 to the power of 1 times 4 to the power of 2 is indeed 4 to the 3. This is a plus,
Uh,
right? But let's walk me through this. Just let me show you, okay? 4 to the power of 1 is what?
4. So it's
Right?
4 plus 16.
Yeah, what is 4 plus 16?
20.
Now, how would I get a 4 out of 20? I can divide it by 4, can I? 5
Yeah.
times 4 is 20, isn't it?
Hmm.
4 to the 1, correct?
Yes.
Isn't that there?
Yes.
So this, 4 to the 1 plus 4 to the squared, is equal to 5 times 4 to the 1, isn't it?
Yeah, but why not
Okay.
just leave it at 20?
Listen, listen, listen. Let's see if that's true for the next case. If I have 4 squared, and notice that the power here is 1 more than this power, isn't it?
Yes.
Oh, now walk with me, Nicholas, because you don't see it, so don't act all like this is useless. It's not. 4 squared plus 4 to the cubed. What is 4 squared?
16.
What is 4 cubed?
64.
64. What's 64 plus 16?
80.
Now, what multiplier times 4 makes 80? 4 times what makes 80?
20.
20. 20 times 4, right?
Hmm.
But I'm trying to get 4 squared. Does 80 multiply is 16 multiply into 80?
I don't know.
80 divided by 16 in your calculator. Tell me what it is.
I'm assuming it's going to be a whole
Yeah.
load calculator load.
What's 80 divided by 16, Nicholas?
5.
Yeah. So can I rewrite this like this? 80, I can say is 5 times 16.
Hmm.
But can't I write the 16 like this over here?
Yeah.
Okay. What did you notice?
Now the exponents are the same.
No, you didn't notice. Isn't this the same as this exponent?
Yeah, that's what I meant.
And then it's a 5 multiplier, right? So
Yes.
it seems like whenever I add 4 squared plus 4 to the next one, it's the same as 5 times this.
Ah,
Yes?
so that means
Now let's go back and look at your problem. Your problem says this. Your problem says It doesn't use a number. Your problem says 4 to the x, 4 to the x plus 4 to the x plus 1. Well, isn't x plus 1 one exponent higher than this?
Yes.
So this is going to be the same as 5 times 4 to the x.
Cool.
That should work every time. With 4 power, if I put a 4 to the power and I add it to 4 power more, it should add up to 5 times the first power. Which means you can rewrite on your paper 4 to the power of x plus 4 to the power of x plus 1 is equal to 5 times 4 to the power of x. So now you can share your screen. We'll see if you follow that at all.
Done.
Okay, so that means you can replace that left side of the equation with 5 times 4 to the x, no?
Yeah.
Is equal to 160.
Yeah.
Okay, so please do so.
Am I tired?
You're very tired. How would you solve this equation? What's bothering 4 to the power of x?
5.
Yeah, so you would do what to both sides?
This.
Yeah. 5 disappears on the left side once you divide it by 5. And then on
Good
the right side,
riddance.
what's 160 divided by 5?
Christ.
Yes, Christ.
What do you mean, yes, Christ?
Yes, Christ.
Yes, Christ.
32. So that's equal to 32. If only 32 and 4 had a number in common that has a power. No, it can't do that. I don't know what you're doing there. They're not the same base, are they?
No.
So,
All right, log time.
no, you don't have to log. 4 and 32 have a number in common.
Oh, right, that too.
Yeah, so 4 is 2 squared, and 32 is what? 2 to the power of 5?
Yes.
Yeah, but now you got to include those. You've just totally wiped out their original exponents. You've got to include the x in there somewhere. On the left side, you've replaced 4 with 2 squared. What have you forgotten? Yeah, okay. 2 times x, it works out. Now you can do it. What can you do? There you go. Now let's ask ourselves, how do we come up with what we to replace this with? Okay, so here I'm gonna disable your screen.
Yeah.
Yeah, relax. And now I'm gonna share my screen.
Oh, I will relax. Trust me.
Yeah, you should relax. You got a little wound up there. All right.
You have Alexa?
Yeah, of course I do. All right. Now we've got this situation. 2 to the 2, or actually 2 to the x, plus 2 to the x plus 2. Let's look at a real life situation instead of the x's. Shush. So we're trying to find some equivalent for this. What is this going to be equal to?
Are you testing me?
No. So let's use 2 to the 2. What is 2 to the 2?
4.
4. It's 4. So 2 to the 2. And now, what's 2 more than 2 as an exponent? It's 2 more than 2.
Ah. Okay.
What's 2 more?
So 4 to the 2, 8 to the
Now it's 4, 2 to the 4, right? 2
Yeah.
more. Okay, what's 2 to the 4?
2 to 4 is 16.
It's 6, yes, 16, right? And that's
Hmm.
20. If I divide 20 out of that, 5 out of the 20, what do I get?
If I divide 5 out of the 20, I get 4.
4 can also be expressed as 2
Oh,
squared.
no.
No, 2 squared, right?
Yeah.
So that means this up here is 5 times 2 to the x again. Actually, it shouldn't be. Yeah, I think it'll work. We should test it out again to make sure, but here's the logic of it. Ready?
We'll see.
Right. I know, we'll see. 4 plus 16 is the same as 2 times 2 plus 2 times 2 times 2.
What?
So that's 4.
Oh,
Oh, and times 2. There. So
this is
that's
just going to be
16, and that's 4. If I take
20.
2 to the power out of 2 out of both of them, I get 1 plus 2 times 2. 2 times 2 is 4. That's 1. 5. That's 5. So you're always going to get 5 over here. So this is true up here. Takes a lot of
Yes.
fiddling to understand it. Okay, let's see if you listened or you're just yawning or whatever.
Tired, so
No, I don't care if you're tired. Don't come to a gunfight without a gun.
I'll go with a spear instead.
Yeah, you get shot.
Fine, I'll go with the staff. Those actually shoot stuff.
So what is 2 to the power of x plus 2 plus 2 to the power of x equivalent to? I just showed you.
I'm not. I was trying to listen, but I still don't understand.
All right. Here we go. I'll try to do it in writing. If I write this, 2 to the power of x plus 2 to the power of x plus 2, what am I saying? What am I saying exactly about those exponents? The bases are the same, right?
You're saying they're equal.
No, I'm not saying they're equal. What is the difference between this exponent and this exponent over here?
One is being added by 2, the other
Right,
is
one is 2 higher. Say that for me. One is 2 higher.
1 is 2 higher.
Right. So if we were to do an example of 2 to the power of 3, and what's 2 higher than 3?
2 higher than 3 is 4, 8.
No, right there.
Oh,
Just the exponent.
oh, 5.
Right. Am I using a real number instead of x?
Yes, you are.
Right. So I'm just trying to figure this out. So really, this is
Where'd
this
you get the 3 from?
I'm trying to find equivalence, right? So this is true, right? Right here.
Yeah.
This is similar to this.
Mhm.
Okay, what's 2 to the power of 3 in
8.
numbers? 8. What's 2 to the power of 5?
32.
Add them together.
8 plus 3, 40.
40. So it's equal to 40. I'm trying to get back to this one right here, 2 to the power of 3. What is 2 to the power of 3?
2 to the power of 3 is 8.
So divide 8 out of 40. What do I get?
So that means you get 5.
Nope. Yes, 8 times 5, right?
Mm,
This is the same as 40, correct?
yeah.
What can I replace 8 with that looks like this?
You can replace 7 to the power of 3.
Right. So this is the same thing. Yes?
Yes.
Well, that means this is equal to 2 to the power of x times 5. It's the same thing.
Cool.
And I can show it to you by showing you where that comes from, but it's a waste of time. Just know that that's the same thing.
Okay.
We can prove it over and over again with real numbers. In this case, I used a 3, and I added 2 to it. So now I want you to look at the top line and be able to rewrite that in your homework. 2x to the power x plus 2 to the power of x plus 2 is equal to 2 to the power of x times 5. You got to share your screen.
Oh, right. Yeah. I got this.
Come on, snap out of it, chemist. Nobody just takes a break from chemistry.
I know. Actually, here, I'll switch the order.
Yeah, so yes, that's right. It helps when we switch the order.
Screw. What the frick is my autocorrect doing? All right. So let's put in 3, because why the hell not?
Now we've got to replace. No, we don't.
Scared.
We don't replace it with 2 to the power 3 and 3 to the plus 2. That was just an example. That was just an example.
Oh.
It was the top line you were supposed to memorize. 2 to the power of x.
Yeah.
Wait until you write it.
2 to the power of x.
Plus 2 to the power of x plus 2.
Oh, I did that.
No, keep going. You didn't do it. I'm asking you to do it because I don't see it there. No.
Hang on a second. Oh, Christ.
2 to the power of x plus 2 is equal to, not 320, it's equal to 5 times 2 to the power of x. Which means I can replace, anytime I see 2 to the power of x plus 2 to the power of x plus 2, I can replace it with 5 times 2 to the power of x. Why? Because we can't solve it unless we get it down to a single exponent. And you might say, well, how do I know that? Well, we're going to have to take a lot more time. I'm surprised your teacher didn't teach you how to explain why this is true.
He did not teach me this.
Well, it's true, which means you can replace where you see 2 to the power of x plus 2 to the power of x plus 2 with 5 times 2 to the power of x. So on the next line, you can do 5 times 2 to the power of x is equal to 320. And then you can tell me how you solve it. No, you're on the wrong line. Yeah. So we're not done yet. Now 5 times 2 to the power of x. I don't know what you're doing. 5 times 2 to the power of 2x. Get rid of the rest of the stuff. Get rid of the rest of the stuff. What are we trying to replace, Nicholas? We're trying to get rid of 2 to the power of x plus 2 to the power of x plus 2. We're replacing it with 5 times 2 to the power of x. Whenever you find an equivalent, whenever you find two things are equal, you're allowed to substitute them. So I want you to write 5 times 2 to the power of x is equal to 320. What did I do?
You substituted.
What did I substitute?
You substituted 5 times 2 to the power. 5 times 2 to the x.
For what?
For 2 to the x plus 2 to the x plus 2.
Yeah, because I found out that they were equivalent. Why? Because it's easier to solve. What do I do to both sides now?
You divide by 5.
Yeah.
Why did my teacher not tell me about these?
He probably did, but it's a real long. It's like a half an hour lesson if I'm going to do it.
Yeah, that's fine. So that's 320 over 5. 64, which means x equals 6. Peter?
No. Where did you get this? Oh, you just jumped right to 2 to the power of 6. Yeah, fair enough. Let me just verify this one little thing here. 63 times 4 is the same as 4. Okay, let me just try it with this. Just a second, sorry. 5 minus 16. 108 is the same as 63 times 16. Got it. Okay. This next one, it turns out that 4x plus 3 minus 4 to the x is equal to 63 times 4 to the x.
Hmm.
Do you want to see proof of this?
No.
Yeah. So I don't know how to teach it to you because I don't know what your teachers taught you. It's a semi-complicated proof. It's hard for me to show in like 5 minutes.
Well, let's just skip this one.
Okay, we'll skip it. How do you solve the next one? By the way,
Solve it.
I believe actually, you know what? Instead of what we just did, I believe your teacher wanted you to use logs there in the last one.
Hmm.
But we'll see. How do you solve the next one? Or not that one, but the solve of the 5 to the t minus 1.
Uh, 5 to the t minus 1.
Has he taught you logs yet?
Yeah, yes.
Okay. So how do you get an exponent down?
You get exponent down, you use the log.
Yeah, show me.
Oh, like
No,
2x
no,
to
not
this.
up there, not up there. You're done that one. Number 10.
All right. I would log both sides.
Yeah, do it. All right. Now, what can you do to the exponent now that you've
So
logged it?
then using the log law,
Yeah,
I can say t minus 1 times.
you should do it on the next line.
Oh, yeah, it's a good point.
Yeah, you get t minus 1 times log of what? You should put it in brackets, by the way, just so you're not confused by it. Okay.
And I can get rid of this.
Yeah. Now, log 5 is just a number.
Yeah, so that means I have to expand it.
Nope. So that's why when you put t minus 1 in brackets, it would help if you always, when you have an exponent like that, just put it in its own bracket.
Actually, wait. I need to,
So t minus 1 is being harassed by a number. What number is it being harassed by?
I'm in this now.
Almost. Yeah, there you go. You divide log 5 on both sides.
I
Now,
wonder
t
if I
minus
can
1
just.
is being harassed by another number. What? Oh, yeah, you can. It's just a number, but I don't know. He wants 3 decimals, so I might wait for that.
All right.
What t minus 1 also is being harassed by another number, or t is now. What is t being harassed by?
Oh, minus 1. So I
Yeah,
actually have to
so
go
now you
plus
had
1.
plus 1 on both sides. Now you can punch it into a calculator. What is log 3.92 divided by log 5 plus 1? And then you round up to 3 decimal places. So you do log 3.91.
Here, and I'll do it in this calculator instead.
Okay, 3.91. Clear,
Oh,
clear, 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 clear.
yeah.
Clear, 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 clear.
Da, 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 da.
3.91.
Yes. I got.
3.92, sorry,
Okay,
3.92.
here. I'm gonna need you to be a little bit more quiet.
Yeah,
All right, divide by 5
you got to hit
log.
equals. Yeah.
Yeah, I know.
Then you got to add, no,
0.48.
no, 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 you got to add 1.
Oh, yeah. So that's probably going to be 1 point. Hold on. I don't think that's
Well,
correct.
do it again.
Yeah, I'll do it full screen.
You're going to need the
Can
numbers, aren't you? 3.92. That's correct. Now
1.84.
you got to round up to the third decimal. So what are you going to get?
1.849.
Yeah, there you go.
I know how rounding works.
I hope so. Because in chemistry, it's a whole different ball of wax, right? All right. This one's interesting. Yeah. Okay.
What is... Oh, never mind. I'll save it for the end.
This one's interesting.
I think I have to do the same thing.
Probably. It's going to get a little tricky.
I know why it will get a little tricky.
Well, if you're logging both sides, you got to log both sides.
Oh, yeah. There, I'll friggin' log everything. Maybe I should get a tree log and just... All
Don't ever
right.
do those puns in class. Okay, the power rule lets you do what to the powers? How did that become? Oh yeah, there you go. This one's a really hard one. Like I'm having trouble seeing what's going to happen here. Okay, you got to get rid of that log 4. But no, yeah, you got to get rid of that log 4.
Hmm. Actually, yeah, this one actually is...
That's really weird.
What idiot designed this thing? I'm gonna get rid of the brackets. It's making me confused.
Okay, well, you got to get rid of the log 4. So you divide both sides by log 4.
Oh, yeah, yeah. I knew that.
Then you got to get rid of the 2x minus 1 on the right side. Whoa, what happened there?
Doing it on the next line. Actually, in second thought, I'll keep the
Yeah, I
brackets.
don't know if we can. I think that's got to be 5 and 4 don't have anything in common. Huh. This is a really hard one. I'm actually not too sure about solving this, but anyway, keep going. Now you've got 2x. Oh wow, where are you going?
Just checking how much questions we have left.
You lots. You got 2x is equal to 2x minus 1 times log 5 over log 4. So you should write it. Next line, get rid of those log 4s on the left.
I will do it on the left.
Yeah.
Good frickin' riddance to you. All right.
And now we've got to get rid of 2x minus 1 as a multiplier. So you got to divide both sides by 2x minus 1.
But what about the locks?
Now those are just numbers. Just leave them on the right side.
Uh, actually, never mind. That side will cancel, so it's not bad yet.
Yeah, so this is the tough part. That's the part I'm trying to figure out. Just a second. I'm actually going to consult Symbolab on this because I'm not quite sure.
Symbolab is goaded.
Well, see, the right side is 1 less than the left side. Oh, I see. Okay. Oh, no, I don't see. Just a second. Oh, yeah, I do see. Sorry. No, I don't see. Just a moment. Just a multiplier. Oh, yeah. No, this works. This is really crazy and stupid, though. Like, this is an insane one. I hope we're on the right track. I'm probably going to have to share my screen. Ready?
Yeah.
This is like, this is a... I'm amazed he gave it to you. So if you look at this phase right here, right? You've got this so far, right?
Mm.
4 to the power of 2x is equal to this.
You're not sharing your screen.
Oh, am I not? I'm sorry. Just a moment. I got to get pulled back up. There we go. So I think you're at this stage, right, where you've got 2x.
Divided by 2x minus 1.
No, let's just leave the 2x minus 1 on this side. Times log 5 divided by log 4, right?
Mm-hmm.
Log 5 divided by log 4 is just a number.
Mm.
So log 5. As a matter of fact, it's actually this. It's the same as this. Log base 4 of 5. That's what it is. How did I get that? How did I get from that to that?
I'm not sure.
Okay, so here's one of the laws of logs that you have to memorize. And it's this one right here.
There it is.
Which means if I have a log base 4 of 5, it's the same as taking log base 10 of 5 and dividing it by log base 10 of 4. So log base 4 of 5, like this, is equal to log base 10 log base 10 of 4. Got to remember that. So that in this case, we've got the reverse. We've got this side of the equation. When we don't see the 10, it's just a 10, right? When we just see log 5, it's just a 10.
Mm.
Right?
Yeah.
Okay. So that means this, which is there, can be written as that if we wanted to.
Mm.
Yes or no?
Yes.
Okay. Woof. All right. I'm going to make it easier on you, okay? I'm just going to replace log 5 divided by log 4 as a number. It's going to be a lot easier. This is the number.
That's a big ass number.
Yeah, but we're not going to use it all. But you shouldn't really use a number till the very end. But we're not going to see it if we don't. So here's how you do it. So here's the next line. 2x is equal to 2x minus 1. In brackets, it's important this at least stays, this side at least stays in brackets, times this number.
Mm.
Agreed?
Yeah.
Just stay with me, Nicholas. This
I
number,
know.
this number is multiplying the first part of the bracket and the second part of the bracket. That's how you distribute it. So this is true. So we're going to multiply the 2x. So it's just the 2 times this number. And we get this number. I'm just going to round up a bit. Minus this number. What did I do there?
You, you just, you expanded it.
Yeah, I expanded it. Now I'm going to subtract that 2.32192x from both sides.
Yeah, that makes sense.
Right?
Yes.
Now I'm going to factor out an x from this side.
Why are you factoring?
Because I got to get x all alone.
Oh, yes.
Hard stuff, isn't it?
No, factoring is hard.
No, but then I got to subtract this if I'm going to get rid of it. I just got to take this number and, well, I'm going to just reverse it. Hang on, there we go. Like that. There we go. That's what 2 minus that number is. Did I get it? No, I didn't get it. So I'll try again. See if I get it over here. There we go. With me so far or not? All I did was subtract
Yes,
2 minus that.
I am very much with you.
Okay. And it's equal to this mess on the right. Okay.
Mhm.
Then x is being harassed by that long number. Get rid of this now. Which means all I have to do is divide both sides by this long number. Because x is being multiplied by this and I want to get x all alone. So I divide both sides by that number.
And then there's the answer.
And
once
there's
we
the
divide it.
answer. Yeah, once you divide it, yeah. So you got to get that. And I know I'm dividing them in the reverse order, but that's okay. This is how you get around that. You divide it by negative, sorry, 0.3219289, close enough, negative, and then you just hit the reciprocal button, and there's your answer. 0.99999, what do you think my answer is supposed to be if I've made some rounding errors?
1.
Yeah.
9.
That's why I shouldn't have converted to numbers. Because if I left it in log form, it probably would have worked fine.
Yeah.
Just remember, do you want to see it in log form really fast or not?
No, it's fine.
This can be replaced when you divide log base 10 of 5 by log base 10 of 4. Can be replaced with the log base 4 of 5. And that's just a multiplier. And then I would just multiply that through and do the same things I did over here, but just leave it in log form. And probably all the logs cancel out to just 1.
Hmm.
Really annoying. Really, really annoying.
As all math is.
No, it isn't. It's glorious. It's the savior of all humanity.
Yeah, because knowing that mitochondria is the powerhouse of the cell is gonna.
Your entire world that you live around, this thing here, it's all math. So I want to see your screen. Why did your teacher go nuts on this assignment?
Good question.
Next one.
That I
Did you
yeah
just want
here
to
it
see how far you could go?
here I just
Yeah, well, don't worry about that one. You're going to have to study a bit. So,
I think this one's gonna be much easier though.
what are they trying to get you to do? Just solve it in your calculator. Okay, that's a good point. You see log base 2. What would you put in your calculator to solve this?
Log of 53.2 over the log of 2.
Yeah, there you go. That's sort of what we just did, but backwards. Well, no, you can do it on your own time. You don't need to do it in front of me. I want to see the rest of them. A plastic visor, light pass. See, this is more important. This is more likely to be on your test. Oh my God, that's disgusting.
What's disgusting?
This question. So, plastic sun visor allows light to pass through but reduce the intensity of the light. The intensity of the light is reduced by 5% if the plastic is 1 millimeter thick. Each additional millimeter reduces the plastic by 5%. So we're talking about a decay curve. It's like 95.95 to the power of x. And each x reduces the intensity of light. So you'd have I times that. My God. Did he teach you how to do these?
No, he did not. He only gave us examples of solving equations, not word problems.
Yeah, so keep going. I want to just see the next one.
That's the last question.
That's the hardest one. So on my screen, I'll just try to show it to you, and that way you can always watch the video.
Okay.
Hopefully. I don't know if this is going to work. So we're going to pull up Desmos because Desmos is going to solve it fastest for us. I'm going to share my screen.
So we're gonna cheat.
Well, no, but you want to understand it. So if we have something that's 100%, that's it, right? It's 100%. So we would say the intensity of something is going to be 100%, but this is saying for each 5%, for each 1 millimeter thickness, right? For each 1 millimeter thickness, we lose 5%.
Hmm.
Agreed?
Yes.
All right. So I don't think that's what they're. It's supposed to be. I think it's 5% to the power of x, like that, because for each x, we're supposed to lose 5% of the last one. So as an example, how much would I have if x was 1? If there was 1 millimeter thickness of plastic?
100 minus 5, so 95.
95. Let's see if our equation works.
And then if it was 2, it'd be 75.
No. So,
Yes.
no. So if you have something that loses 95% of it, or 5% of its capacity, it becomes that. But when I lose 5 more percent of 95, I have to take 5% of 95
Oh,
to come up with a new one. So it's a little bit less. So it's going to go 95, 90.99, 85.66 sort of thing. But let's see if this equation does that. I don't know if it will. So we can see that at 0, it still should be 100%, and it's not. 5. There we go. So at 0, it's subtracted 1. So that's not what it should do. So it should be 100 times 1 minus 5 to the power of x. Let's see if that does it. That does not do it. It should not be 5%. It should be 5 over 100. There we go. Oh, it went up, though. It shouldn't do that. Oh, because it's multiplying x. And I want that to be a power of x. Let's see if that did it. No, it went up. It's not supposed to go up. For each power of x, oh, this is going to be, yeah, it's going to be 100 minus 100 times that. 5%. Yeah. I'm going to have to work on it more because I'm not sure how you would reflect something that's losing 95% each time, or 5% each time. I think it would be maybe times 0.95 cents to the power of x. Yeah, there it is. So if you look at this as plastic's 100% at 1 millimeter thick, it's 95%. At 2 millimeters thick, it's 90.5. At 3 millimeters thick, it's that. So this would be the equation here.
okay.
The intensity of this plastic is equal to 100 times 0.95 to the power of x. In other words, it's going to go down by 5% each time.
Okay.
Now, the question that you're asked, it's asking a specific amount, I think. I can't remember exactly what it was asking. I'd have to pull up the textbook. But you should be able to answer the questions based on that equation. 100 times 0.95 to the power of x. That is a substance that's losing 5% based on each millimeter of thickness as it goes up.
All
You
right.
should be able to answer the specific questions using this equation. Good luck. Feel free to shoot me a question if you can't solve it, and I can do a video explaining why if you want. I can do
All right.
video if you want explaining why 2 to the power of x plus 2 to the power of x plus 1 is equal to 5 times 2 to the power of x.
Yes, please.
You want to see that? Okay.
Yes.
Bye, Nicholas.
Bye.
Take care.
You
Oh,
too.
wait.
You're searching up for dad jokes, aren't you?
Yeah. Oh, here's one. Shout out to my fingers. I can always count on all of them.